Hello everyone, I'm David from the package team, and in today's video we are going to go through a pair programming session about GraphQL. With me today we have Dima and Rahul, so hello. And we are going to tackle this issue, which is having a GraphQL mutation to delete packages in bulk. So delete multiple packages in one request. From my knowledge and discussions that we had here, there is some things that we need to take into account. So first, the arguments will be simply IDs. So clients will be able to give just a list or an array of the package IDs. And the second thing is that even though it's an array, we are going to limit to 20 packages per request. This is due to the scale at which we run .com. Obviously, we don't want someone sending like 10,000 packages to destroy to the to the mutation. So we have to put some limits in place. Okay, so GraphQL. I don't know which level of your GraphQL knowledge is, so I guess I will be trying to summarize some concepts. If you have any questions, just stop me and we can go into details. I'm not sure how much of the implementation we will get done, but we'll see. At the end, I will finish the implementation today, and I will open an MR. And yeah, since you're working on this with me, you will be credited on that MR too. Okay, so GraphQL. So GraphQL works around I guess 2 types of requests. It's basically either you read data or you modify data, whether it's an update or it's a destroy. That's the 2 types of requests. Better said, 2 types of queries that you can make. So the read requests are called queries, short and simple. The other ones, the ones that do some writes, they are called mutations. Here we are going to delete packages, so we are going to introduce a new mutation. On GraphQL, you have this document that usually all GraphQL APIs should provide, which is the schema. And the schema will list all the queries, all the mutations, all the parameters, all the return types that the server can return. On GitLab, we do have access to that schema. Actually, on gitlab.com, so this is .com, we have access to this GraphQL Explorer. So this is a small GraphQL editor that the GraphQL gem provides. And you can actually browse the schema. It's here. I guess it might be, yeah, might be too small to be readable. You have the schema here. So you have the queries, you have the mutations. We will leave subscriptions to aside. So queries are quite simple. You really navigate through objects. So let's say you can query the project, which is here. This will return a project type. And if you open the project type, you have then fields. And I'm taking a field randomly, right? But we are going to read packages. So in the project tab, we can read packages, and this will return a connection. That's a short term to say that it's returning a list of packages. So the word list or array or whatever collection you want to consider, it's called connection in GraphQL. So if we open it, yeah, if we open the connection, we have some fields that are used by the GraphQL clients. The most interesting one is the nodes that contains the array of package, and here are our package. So how this look like on a query? So you first write which type of query you want. So here we want a query. Then we said we want to access a project. Actually, I'm going to do this on my local GitLab instance because I prepare a project with packages so that we can play around. So it's the exact same Explorer. The only thing is that it's on my local GitLab instance. So the query, then we have the project. So inputs will be, it will be given as parameters. So you will have an input here. There is only one, which is the full path. That's a good question. What is the name of my, I think is here. That's the path of my project. Okay, and then we open, it's like opening the project value that is returned, and here we are on the project value, so we can ask for the packages, which will return a connection. We open that connection. We are interested in the nodes. We open the nodes, and here it's the fields of the package. So we just list whatever field we want. Let's execute this. And so we have two packages on that project. That's a query. The mutation is exactly the same. It's just that mutations have more complex inputs because usually mutations can be, for example, you can update an object, so you will need to pass as an input all the updated fields that you want to update. So it's similar with more complex input objects. Okay, no questions so far. Okay. On GitLab GraphQL, we do have a style guide. I will put the link with the video. This goes through a lot of stuff that we use at GitLab. So yeah, have a read. There are several things and custom things that we do on GitLab. So it's handy to have this page on the side. Okay, so we are going to build the mutation. I'm going to take a shortcut here because I know that we do have the mutation to delete multiple package files. So I'm going to have a look at that. So it's GraphQL packages destroy files. Each GraphQL type is mapped to a Ruby class. You can basically have it where you want, but we do have some code organization at GitLab. Otherwise, that would be the Wild West, I guess. So we do have a namespace for mutations. Then it's pretty much split into functional area. So we do have one namespace for packages, and then we have all the, you can see that we have all the mutations here. So basically destroying things. And what is this? Oh yeah, that's an update on cleanup policies, which is also a mutation. On the class, you are going to use a basic class provided by either the GraphQL gen directly or a custom parent GitLab class. And this class will provide you many helpers. So, for example, we can see that we can define the GraphQL name. So that's the name of the mutation that will appear on the schema. We have authorization. We have the arguments listing. So that's the inputs. And then the most important function is the resolve. So the resolve function is basically taking the inputs of the mutation and just execute the mutation and returning either a message or an empty array or errors or whatever. The inputs of the resolve function are exactly the ones that are stated as arguments for the GraphQL schema, which makes sense because like this is the exact inputs that we receive from the GraphQL mutation. So those are what you are going to receive in the function. We can keep that and get inspired. No copy. We don't copy code. Code duplication is bad. We just get inspired by this class and create one that does pretty much the same thing, but it works on packages. Yeah, I guess let's do it.
Can you repeat what the include finds project does? Line 8.
Yeah, so this one, that's a custom helper on GitLab. So we do have a lot of queries and mutations that use a project path as
Yes.
as an argument. And so this thing provides, it's the find project based on project path is to find a project based on this input, and that will get executed by this line, authorize find. It's not super clear because it's like helpers using helpers, and so it's not super clear, but this thing will call, I think it's called, it expects to have a function called find object, and it will actually find the object and check this permission on the find object and just fail if the user doesn't have the object. We can check on the, I think we do have that on the destroy package file. So same mutation, but this one is just for one package file. So there is no project path, so we don't
include that.
Find the project path. Instead, what we do is that we find the package file directly by its ID. And you say this is the function that this method expects to be defined. Find object, and it's actually using the same inputs, the same parameters. So here, since we didn't use the project helper, we define the find object directly, but here, since it's the project path, we can use the finds project. I guess we can open it. Let's see what this has, but I guess it's almost just find object, you see.
Yeah, it's just find object. Yeah.
It's just a way to avoid everyone to define this function on their mutation.
Yeah.
But yeah, there is something to know. It's that the authorize find. Well, actually, you can always check for it. Authorize find. You can always search for the function. Oh, yeah, of course, you will not find it. Okay, the fuzzy search doesn't want to work with me.
Authorize.
You have the typo. You
Yeah,
missed the D in the end of
D,
authorize.
Oh yeah. So it's actually me that doesn't know how to write. So it's yeah, as I said, it's finding the object. You see this the call here on the find object method. Another object that has been fetched, we will call the authorize, which is just below. And it's actually, oh, that's okay. I like those constructions where you have functions that are only one single line, but okay, why not? So it will just check if we do have the authorization on that object. The current user is something that you more or less always have on all mutations, query resolvers everywhere. So that's something given. Actually, it's called here, and it's like it's defined by the. I guess it has to be a GraphQL callback made by the, GitLab, so that we do have the current user, and then we do have the authorized that will define which permission we need to check. So the authorized find will always get the object, check the authorized, write, and return the object if everything is fine. Otherwise, it will trigger an error, and you will basically just bubble up an error. So stop the result function. Is that clear? Or
Yep.
Okay.
Makes sense. Yep. Thank you.
Yeah, we can keep this one. So we are going to have a destroy. That's the hardest part of implementation.
Yeah.
Is naming. Like I'd like to put like destroy, I don't know, packages.rb. Yeah, why
Yep.
not? But
Right.
we do have packages twice. Like
Yep.
I'm as I said several times, I'm a simple man. Like duplicating packages doesn't bring value. So yeah, well, we can go with bulk destroy, I guess. Yeah, that should be quite explicit. If you have some ideas, don't hesitate to to give me names. Yeah, well, let's go with this, and we'll see. So yeah, I'm super lazy, so I will start copying. Oops, copying things. The only thing is that the class is bulk destroy. Is destroy packages. We don't need this. We will discuss the authorize shortly. We said that we don't have the project path. We do have IDs. That has to be an array. So a very quick word on arguments. So you give a name, which is the one that will be used on the schema. Then you have to give a type. So yeah, I guess we can start with imagine that it would be one single ID that is given. So that would be this thing. So we need to say that this is an ID from a package. That's good. But we have to say that it's a global ID. So another another side subject. What is a global ID? So you can think that we could use types. I think there is string. Yeah, that would work. but the global ID is basically a smart string. We can see one here. This is a global ID. So it's a string, that's true, but it's a smart one because it will actually embed the type and the ID of the object. So this is the global ID of this model and this primary key. And just with this string, we can load the object, no problem, because we do have the model and we do have the ID. And that's why we want here a global ID, and we need to state which model we expect. Now, it's not a single ID that we want, it's multiple ones, though, so it's basically giving an array of classes. And here it's just an array of the global IDs of the package. Yeah. Required. The schema allows you to say if you expect, you can have multiple fields, and you can say, okay, this field is required, I need it all the time, this input field, and this input field is optional. That's basically the required thing. Here we only have IDs, so yeah, it is required, otherwise we can't do anything. And then the description, it's useful for the schema because you will get the description there. It's the sidebar that I opened previously, like exploring the schema. We will see the description. But the other thing is that we are going to generate some documentation out of this description, and the tools that generate descriptions will read this field. So this way, the documentation on the handbook is updated for us. So there's less thing to take care about. That's the result. Let me close everything. Okay, so we don't have project path, we just have IDs. Now, destroy package. Yeah, so that's the right permission, but we can't work, we are not working on a single object like we do here. The authorized find is for a single object. For multiple objects, we can do that. So we are going to do manually what is done automatically here, more or less. So we need to get the packages, then get the projects, and then verify the destroy package permission on that. If all is good, we can proceed, and we can call the service that will delete the packages for us. So yeah, well, I guess we can, yeah, we can do that. So actually, it's pretty close to what we have here. Yeah. So it's parsing the global IDs, okay, to extract the model ID, and then it's using the model class directly. Yeah, that's not really recommended. We usually need to use a finder. So a finder is like it's like a service class that is highly specialized to just fetch objects. That's it. Services do, well, whatever logic you need to do. So yeah, I would suggest having a finder to do this line, and that's actually why do we have a Robocop guard on this thing. It's like we are not allowed to call the model and create a query from anywhere. The GitLab code guidelines expect these lines to be in finders or in models. That could be also possible. Okay, so let's do this. I guess the first thing we can do here before any parsing is checking the amount of IDs that we receive. It's exactly this line. Actually, I'm going to copy it. I'm lazy this morning, so let's copy everything. So maximum then packages, maximum packages, that would be a constant that needs to be defined. Yeah, here. This we don't need this because we are not going to use the authorized find. Why we do that here? Because parsing global IDs is not free. It's like you are spending some processing to do that. So even before doing that, we can already check for the size. If all is good, we can, I guess, yeah, we can pass the IDs. So basically the same thing that we have on the other file. But I think I will do slightly differently. So same thing, model IDs from the IDs. So IDs not oh. Okay, great. It's better like this. I'm not happy with this because it's a duplication first. That's one thing. And the other thing is that I think we could have a past GIDs as a helper directly so that we don't need to do that. It depends on how many mutations or queries are built around arguments that are an array of the IDs. Yeah, we'll probably refactor that to have a past GIDs anyway. And then on DMR, I will just pass it on to a GraphQL expert, and they will tell me, oh, this is a bad idea, this is a good idea. So I will refactor that later, but we can keep that for now. GIDs, so we are going to get the packages. Now the thing is that I don't think we have a finder for packages on IDs. So finders, packages. Yeah, we do have one, but I don't think it works on IDs, right? No, it works on giving the project. Could we reuse this? That's a good question. Let's say that we add a param that is the IDs, and we implement a filter by IDs. Boom, boom, boom. Yeah, that could work, I think.
One question,
Yeah.
wouldn't that add additional, since it applies some default sorting and ordering, would it apply some kind of additional slowness, which we not really need? Because for us, the order doesn't matter for the bulk destroy operation. But I mean, if those fields are like, if there is some kind of index
Yeah.
on the database level.
I guess so. You are right. It's going to add an order on the final SQL query. But to answer your question, we would need to run the database review.
Sure.
So we will need to go through the analyzing the query itself. The created at is indexed. That's something I know. So it's context knowledge. So I'm not sure that we are going to lose that much performance. And actually, will it matter? So the thing when you work with collections in GitLab, there is one thing that to have in mind is that you don't work on the collection directly from the database, because yeah, locally we might have 2 packages and that's fine, right? But on .com, you could be working on collection with thousands of objects. So it depends how the service will take this query to destroy the package. We could implement the service so that instead of doing like a giant update all query, it will do a batch loop. And if there is a batch loop, then the sorting will be overridden by the batch loop class helper. Yeah, I guess that's something to take into account. From my knowledge, I think the default sorting will work just fine. But I would still, and actually I will do on this amount because that's a new query. We will need the database analysis so that we know that, okay, this query is fine. What is more, what bothers me more are the including. Because sometimes these are preloads, and like preloads will trigger an additional query to load the project route. I guess those includes are from the model. Yeah, it's not go to that. It's including project now. Okay, those are includes. Yeah, I'm not happy with this because we don't necessarily want includes in this case, because we just want the package. We are not going to read the project route or the tags. That's something that I have in my mind, is that this finder needs this part to be mounted on, not mounted, but it needs to be optional, so that if clients want it, they need to tell, hey, yeah, I want this, or I want to disable this. Just like the pipelines, you see the pipelines are preloaded only if we have the parameters to preload pipelines, which is in this case, we are going to disable it because we don't need pipelines at all. So yeah, the thing is that the mutation will need a finder and the service. My idea for this session is that I don't want to spend too much time on those 2 things because they are like additional things out of GraphQL. I wanted to focus this session on GraphQL, but you tell me if you want to go into details on finders and services, that's fine too. It's as you want. My idea was, yeah, I can quickly perhaps update this finder just to make it work. but then I will either create a new one, modify it so that this thing is optional, because I really don't want this to be executed. And on the sorting, it depends how the service is implemented. If we have a batch loop, the sorting can be anything because it will be overwritten by the service. Otherwise, we need to we can still use the order by ID and ascending, which is like the natural default order. So we can still use that. That is still good. So yeah, well, let's modify this one so that it works for our small change here. Filter by, let's say that it's IDs. Probably this is specific to this finder, so I'm not going to add this to the. We do have a module or a concern or whatever you want to call this. It's a Ruby module that is included in different helpers to provide these filtering methods, but filter by IDs. Yeah, that's not that often that we need to do that. So let's keep it here. So we just need packages. Yeah, let's keep it something simple, ID. And we will need the IDs, right? Yeah, I guess it's something like this. And we need the IDs, params. I don't think we need a fetch. We can directly just do this. Am I doing this right? No. It's here that we should have something. Yeah, otherwise we can return null. Oh yeah, even the where on finders, no, you don't do that. But we do have a scope, that's fine. It's just that it's always a different one. Actually, it's a global scope that is on the application record. And I think it's ID in, yeah. IDs. I don't like single line functions, as I said. This is like more confusing. So let's keep it simple for now. Okay. Okay, fine, we can use that. This one, we don't need you. And here we can simply say that we want packages. Oh, but it's not going to work. Yeah, because it reads the project and take the packages, and here we only have IDs. So this is not going to work. Okay. Yeah, I need to think if we need a new finder or we modify this one, but making the project optional is a bigger change, because this finder has the project as a, you see, as a like main parameter, main input. It's like it is centered on project. So yeah, probably I need a new finder. But well, for the sake of making this work and continuing, I'm going to use the where directly here. Package file, ID in, model IDs, kids. That's it. I will remove this and this one because it's not useful. Okay, we do have the packages. Then we need to pass this one to the
Sorry,
service. Yeah.
Should
like package file or package?
package, yeah.
Oh, yeah. Yeah. It's package. Yeah, that's correct. You notice that I didn't check the permissions yet. That's right. My idea is to have them checked in the service, which is something that we can do. Let me show you what marking one single package looks like. It's this one. So in the package registry, we don't destroy packages directly because we do have files, and files are linked to object storage. So we can't delete them within the web request because that's a bit too many operations in one go. And here we are actually trying to destroy multiple packages. So that would be even more operations to do in one go. So instead, what we do is that we mark them. It's like flagging them for destruction. This will make them unavailable from the package registry. And then we do have a set of cleaners, background jobs that will take care of all the objects that are marked as pending destruction. Well, when I say objects, it's workers for the package registry. So they will work on packages and package files because both are using the same system. So this service is for marking one package. And you can see that there is the, here there is the authorization part, so checking if the user can actually delete the package or not. Then we have a few things to do, like marking the package, updating the right column to pending destruction, and then we do need also to mark the package files. Yeah, that's correct. And we need to sync that's for Maven packages. That's something specific for Maven. In very short words, Maven has a file that will list all the available packages. So if you delete a package, we need to remove that package and version from that file. So this function will enqueue a job that will just do that for us. Well, I will not go into details on those lines, but this line is a SQL update standard thing. This one is enqueuing a background job. This one is enqueuing a background job. So this service, at the end, it's only doing one SQL query and two jobs that are enqueued. So we need to do the same, but working on multiple packages. Is that clear? Or
Yeah.
Okay. So let's create in the same place this way. Packages for mark packages for destruction. Yeah. Yeah, again, I'm lazy, so let's have this thing. Yeah, actually, I will just copy everything and modify as we go. So it's packages, the container. Yeah, I'm going to skip this thing, but it's actually we do have parent class to define services, and this parent class has a specific parameters for the initialize method. And so one of the parameters are the container, which is like the main actor that you want act upon. Like this service want to work on this actor or this object. So the object is called container for the base container service. So because I don't want to have container everywhere, I just put an alias so that I can call packages and it will just get me the container. So first thing, we will have a user. Yeah, that's correct. And we will need to know if the user can destroy the package. So obviously we can do packages.project. That doesn't work because packages are a collection. So what we are going to do is that we need to either loop on packages, get the projects, and then check this permission. But could we do better? That's the question. So what I had in mind is something like this. So first, getting the project IDs, you just packages, block the project IDs. This will trigger a single, an additional SQL query, but it will select the project ID only for you. So this is an array of IDs. And then we just need to ask, we can optimize things by compacting this, which means that we not compacting, unique, which means that we don't want duplicates because you don't want to check the permissions twice, although we don't have any performance penalty because the permission framework will actually cache all evaluations. So if you check the destroy package against project A, and then at a later time you check again, the first evaluation, the result of that evaluation was cached. And so the second one is almost free. The cache is checked and there is a hit and you will get the result returned. But well, since I don't want to ping the permissions part multiple times, we can just have unique project IDs. And then if I'm not that rusty, I think we can use all, right? And just all here, we have the project ID can current user destroy package. We need the project, of course. Right, that would be fine. Project. We need to load the project. The project objects first. Yeah, we'll take again a shortcut. I think there is a better way to do this, but let's do this. So we load all the projects and then we ask if all. So we don't receive a project ID, but a project, and we check if we can destroy the package on this. Yeah.
With plug, we don't return unique elements, right?
No.
But probably we can, I'm not sure exactly, but somehow we can we can get the unique, distinct, exactly.
Yeah.
Would it make sense on the to do that on the database level?
Yeah. We could do that. The only doubt I have is that the plug will. I'm not sure if that you can customize the query that plug will do. What we could do is
select distinct.
Select and then distinct. Yeah, that works too. And then we just don't need the unique here. Yeah, that's good. Yeah, probably I will need to refactor this because he's not happy that I'm calling an active record method from a service. We will need something in the model or whatever. But I want to go a bit faster here so that we can connect this to the GraphQL and make it work. Okay, so that's one thing. And yeah, it's not this, it's these packages. Okay. Yeah, here I will need to think about it because that's something I know. I want to reuse this service on cleanup policies, and cleanup policies, we are not going to work on 20 packages max. We can work on like thousands of packages. So yeah, for now we can packages each, which is not that great, right? We can just package, yeah, take everything here up to this one, put it here. Yeah. Yeah, again, this is a shortcut, but I will not create the MR with this because we should really avoid each on collections that you don't know the final size. For our case here, it's fine because we limited the IDs to 20, so it's fine to do an each. But I know that I want to reuse this service on cleanup policies, and there it's not 20, is like any number, it's arbitrary. So we cannot have an each here. We need to have something else. Probably we need the each loop. I'm quite sure that we will need that. The each loop is basically, I can show you quickly here what is, no, each batch. Well, it's not for each, it's each batch. So basically it's almost the same thing, but you ask for a batch. It has a default size, the batch has a default size of 1000. You can customize this, but you will receive here the batch itself. So it's packages, and then you do whatever you want to do on this batch. So probably I will do that and streamline this one because this one is an update. So instead of having that many updates, we can just pack all together in one single update. This one, I will probably have a way, there is a way to include multiple jobs in a single call. I don't want to include them one by one. It's similar to the SQL aspect, like include them all by one. But for the sake of keeping things short, I will just use each here, and well, that's fine for our case. Let's go back to our mutation. Mutation, where are you here? So no, you are not here. You are here. So we do have the packages, so we can just so there is a response from the service. Packages, mark packages for destruction service, new. Now my memory is failing. That's where the base container service works. It's the order and the parameters that we need to give. So I'm going to
Should it be package?
No, I think the first one, well, okay. I didn't want to do that, but I guess I will just open the base container service, check the initialize, and that's it. So it's all keywords. Okay, so container, packages, current user, and do we have params? No, I don't think we have any. Okay. Yeah, that should be good. And then with the response, so yeah, I guess result is a better one. So the result will return, it's actually an object that where you have a status on it, so you can check if you have an error or not. I think I'm missing. Yeah, I'm just this is just the service, but you need to actually execute it. Yeah, that's a very common pattern on the GitLab, in the GitLab code base, like building a service and calling execute. It's such a pattern that when you create a service, you are expected to have an execute method inside of it. It's like the most common thing to have. So I guess I will just, yeah, I'm lazy, copy everything because it's really the same thing. It's basically reading the status, if we do have an error or not. If we do have one, we can have messages, and then we return a structure with the errors, and that's it. Okay, good. And that would be our resolve method. Last thing, this is a new mutation that we need to put in the schema, right? Because we do have mutation here, but if you look for destroy packages, no, we do have the others, but not the destroy packages one. So this is very simple, since it's like every object in the GraphQL schema is mapped to a class. We do have a query type that is a class that will actually have all the queries that are possible. And we do have a mutation type, I guess. Yeah. Same thing, but for mutations. So yeah, there is a bit of ordering here. So let's put everything together. We do have the destroy here. Let's put our bulk destroy here. Okay, I think we're good. So what we can do is just reload the editor. The editor itself will query the GraphQL server. Hey, give me the new schema, and we should see our mutation here. When you work on GraphQL, this is very handy, because this loading, if it fails, that means that something went wrong with either your declaration, your mutations, or I don't know, the arguments or something. Here it has all loaded, so our mutation is a valid one. It was properly loaded, and we can search for it. It's destroy. But yeah, of course. No, it's bulk. No, wait, it's destroy. The GraphQL name is destroy packages. Here it is. So the input, this is an object that is created for us. The input is the arguments that we ask. You can see the IDs here. You can see that is an array, and those bang symbols means that this is required. So the array is required, and even one element is required, so that clients can send a null IDs, and they can send an empty array that would be invalid. So we can try this now. Let me get the the global IDs because I don't recall them. So that's my project. So mutations, same thing, but we start with mutation. Okay, and then our name, destroy packages. Yeah, so this name is actually the name we used here, the GraphQL name. But you can see that we can organize the code as we want and have a different name. That's fine. Destroy. Then we need an input. That's correct. We should have this can be ignored on the editor. This is used by the Apollo GraphQL client, if I'm not wrong. So we can just use IDs and then just pass an array of global IDs. This one, yeah, thanks. That's great. 29. Okay. Then this will return something, which is the errors and structure which we expect to be empty. Yeah, so like this. Let me check if here, yeah, no, this one actually. Yeah, I do have the logs in case of I did something wrong, and I did. Yeah. Oh, the constant maximum packages. Yes. Yeah, I think there is an if here. This line is too long. Rubocop is. You can see that it's complaining that it is too long, but that's fine. So let's go back here. We don't need to reload. That would be useful if we want to reload the schema, but here, when we execute the request, the Rails backend will actually reload everything, and it will reload the mutation class, so that's fine. We can just go like this. So it's reloading, I can tell from the timing. Again. I expected to have errors in the like finders and services, not here, right? Yeah, these IDs. Will it work? Will it not? Woo! Errors, nothing. So we can check the logs. We can see that the packages were updated. So that's good. That's what we want. But again, we can see here the effect of that each loop on the collection is that these lines and these lines are similar. So instead of having a single update, we can have a single, instead of having multiple updates, we can have a single one. I think we are good. I'm wondering why the project is loaded twice, but I guess it has to do with the each loop. We can see that the projects for the authentication part has been they have been all loaded in one go, so that's good too. We have the distinct here, select distinct project ID. So that's good. So we basically the implementation on the GraphQL side is done. That's good. The only thing missing is the refactorings, because I took two shortcuts here for the finder and in the service for looping on the packages. And then when this refactoring is done, we will need to create all the specs. But well, since we are out of time, I guess we will need to stop here. Yeah, well, so that's basically the how you work with GraphQL. We can have a quick word on specs. So specs for GraphQL is basically you are going to have specs on two levels. One of them is the mutation itself. It's like it's almost initializing this class and calling the resolve function. Basically, that's what you will do. And the other level is running at the it's like running at the GraphQL controller level, where you actually send the query to the controller and say, hey, it's like doing what we did here. You send this and you expect, you just check the response. And this will allow checking that the schema was correct, that everything is connected together properly. It's a request spec. So I would say that it's more on the integration side, because you check everything. You check that everything is properly connected. Whereas the mutation spec is really, you take the mutation class and just see how it behaves. And that's about it. I don't know if you have questions, fears, concerns, anything.
I have one.
Yeah.
I have a question on so there is a GraphQL API documentation file like that gets updated. So how do you?
Oh yeah. Yeah, good question. So here we do have our changes, and we do have it's a rake task. The only thing is that I don't remember where it is. What is the name? No, I guess.
Okay. Yeah.
Oh, let me check. We can still do something. Yeah, I guess it's not. I don't know where the font is, the font size. Grep, I think it's GraphQL. It's something with GraphQL inside of it. But no worries. Actually, this is checked by Danger on GraphQL changes. So Danger will detect that there is a change. And so it will tell you, hey, you forgot to run this. So we have actually three things. There are these ones. Yeah, the schema, there are two formats. There is a JSON format and there is the GraphQL format, which is basically what we see here when we create queries. Same thing, but with everything that we can do. So we do have two tasks for update those schema. Actually, we do have one for dumping the schema in those two formats. And the other one that we will need is the compile docs. So it's GitLab GraphQL compile docs. If you run that, yeah, perhaps with the rake executable. Okay, so while it's doing this thing, it will update this documentation. It's GitLab GraphQL. I can type today. It's impossible to me. This one, the reference. So the reference is actually everything. So we can just check for the destroy package files. That's the mutation. You see, you have the list of arguments with their description. That's where the description field is used, and what is returned. And those are links to, so you can click, oh, this is a package file ID, it's a global ID, and here is an example. So it's updating this documentation, whoops, here. So it's a simple wait task. And now if we check yeah, you see the reference index has been updated with our changes. But no worries, DangerBot will run a check on that. It will actually generate the documentation and check with the current one. If there is any change, it will tell you to run those commands.
Yeah, cool.
If you have any doubt on the GraphQL MRs, because we have many custom options and things that we can use at GitLab, don't hesitate to use a backend maintainer that has a GraphQL expertise. We do have a few ones, so I would say that for simple things like a new query or adding a new field that you can return in a query, that's fine. Anyone can review that. But for more complex mutations or more complex access, like sometimes you want to access really nested objects, but at the same time you want to avoid n+1 situations, things like that. Yeah, probably use someone with the someone being a GraphQL expert.
Thanks.
Yeah, you're welcome. Any other question?
I have one question.
Yeah.
Would you mind to go back to the editor?
Yeah. The code editor or GraphQL editor?
Yeah, to the code editor. We implemented kind of the strict rule that if the amount of IDs is more than defined, then we just raised an error.
Yeah.
What would be your thoughts on to make it slightly softer, for example, and still accept the request, but kind of partially accept the request and still delete some amount of the packages, and together also like raise an error that only this amount allowed, but so, you know, kind of success plus combine it with error. Just any thoughts on that?
Yeah. I think that could be something to be discussed on the issue with Tim and Katie, because they are responsible of the UX. In this case, the max amount of 20 was not chosen randomly. It's actually the amount of packages that can be selected on the front end for destruction. And so ultimately we want to implement that front end feature. So these backend changes are supporting that front end feature. And yeah, for the first iteration, we decided to start with what the front end needs and limit to that. If then users come back and, hey, I want to delete like, I don't know, thousands of packages, we can look into that and see how the system reacts. But I guess it's part of the iteration value. The first iteration is super simple and it's the front end needs, and that's fine. The only extra bonus here is that that service that delete multiple packages, I already know that we are going to use that on cleanup policies. So if we can take into account the scale of the packages, the query that we receive, that would be way better. So that each loop will definitely need to be refactored.
All right.
Okay. Well then, there are no other questions. I will stop sharing. And I guess this is the end of our session. So I will stop the recording. So bye everyone that made it to this point. Congratulations. And see you on the next one. Bye.